In 6.4, we're only going to be dealing with functions that have one variable. So we're kind of going back to our stuff from the previous chapter. Functions that we can graph, things like that. A little more consistent than the polynomials and monomials that we've been dealing with the last couple days. And one of the prerequisite skills is that we have to be able to state the degree and leading coefficient of a polynomial, which is a skill that you all have, I assume, but we have to make sure of that before we move on. So if I have the function f of z equals 7z cubed minus 4z squared plus 6z, and I want to know the degree and the leading coefficient of that polynomial, the degree is the highest exponent you see, which is 3. That's right. The leading coefficient is the coefficient that is right on that same term. The same term that got you the degree of 3 would also give you the leading coefficient. That term gives you both of those because that term is the boss of the entire problem. Everything about the graph of that polynomial is determined by that term. Okay? So you try one. Find the degree and the leading coefficient of g of a. And for this one, the degree is 3, and the leading coefficient is 1. Next skill we have to be able to do is take a function and find a specific value. We've already done this year, but we need to review it. So to find b of 2, we would simply substitute the 2 in where we see an m. So to find b of 2, we would say 2 times 2 squared plus 2 minus 1. Now, looking at that first term, a lot of kids are going to get that wrong because they're going to say the first term is equal to 16. The first term is not equal to 16 because you do not go 2 times 2 and then square it. That's not the order of operations. The order of operations says you square the 2, get 4, then multiply it by 2 to get 8. Plus 2 minus 1. So the value of that question right there is 9. You try this one. You should be getting 18 for the first term. If you got 36 or negative 18, you are making common teenager mistakes. 18 minus 3 minus 1, 15 minus 1, 14. Try this one. Find b of cracked egg. Correct answer, 2 times cracked egg squared plus cracked egg minus 1. Wing ding, just to lead into the more difficult question we're going to do next, I want you to find b of 2x minus 1. I put a 2x minus 1 everywhere I saw an m. Then I'm going to have to square 2x minus 1. That is not just squaring a 2x and squaring a 1, teenagers. That is taking 2x minus 1 times 2x minus 1 like we did in 6.2 just a few days ago. So you have to distribute, like we just took a quiz on Friday. Combine like terms. That is equal to 4x squared minus 4x plus 1. Still have the 2 out front of that. So we have 2 times 4x squared minus 4x plus 1 plus 2x minus 1 minus 1. And now we pretty much kind of have to just clean up the mess. So we would distribute our 2 like so, and just throw that stuff on the end, and now combine like terms. So all you really have to do in this problem is substitute the 2x minus 1 in, FOIL, clean up the mess. 8x squared is lonely. We have a negative 8x minus 2x, which is a negative 6x, and 2 minus 1 minus 1, which is 0, which you don't need to write. Correct answer, 8x squared minus 6x. Okay, let's start talking about graphs. First, I want to share with something with you that I've been sharing with you all year leading up to this section. And that is that the number of roots or solutions or zeros, real roots, solutions, or zeros of a graph is the same as the number of times the graph hits the x-axis. We've talked about that multiple times. We've graphed parabolas and told where it hits the x-axis. And I've always told you that where it hits the x-axis, that is a real solution. Okay? I've been telling you that leading you up to, really, the start of today, where we start talking about more complicated graphs. So, that graph has how many real zeros? 3. Everybody with me? Crosses the x-axis 3 times. 2. 1.
4.
That one has 2, but a swing and a miss there in the middle where it tried to hit the x-axis has 2 imaginaries, which we're talking about real solutions now. Thank you. You were good when you said 4. The question is for real zeros, but that one does have 2 imaginaries. That one has 0, but it has 2 imaginaries on the swing and the miss, trying to get down to the x-axis. That one has a double root, which counts as one unique real solution that occurs twice. So if you have a double root, it counts as one root. Like that one right there has 2 unique roots, but you know that each one's going to count twice, so you know it has 4 real solutions. Okay?
Wait, will you repeat that?
That one has 2 unique solutions, but each one is counted twice, so you know it's going to be a 4th degree equation because it's got 4. Each one's counted twice.
So the other one,
the down parabola has 1 unique solution, but it's counted twice, so it would be a 2nd degree equation. Now what we're going to do is we're going to describe the end behavior of a graph. Does anybody know what end behavior is? The end behavior is how the ends of the graph behave. The ends of the graph would be the arrows. So as the graph shoots off to infinity, where's it going? Well, almost all of our graphs are going up or down. So we're going to try to figure out where our graphs are going based on the equation. To do that, we have to know the difference between an even function and an odd function. An even function has an even degree. It's pretty complicated. So any function with an even degree, both arrows go the same direction. Either both up or both down. A very simple example of this that you would understand is a parabola. A parabola is a quadratic, which means it is an even degree. And you know what a parabola looks like. Both arrows are going up or both arrows are going down. And that's true for any even function. It does not have to be a degree of 2. It could be a degree of 38. Both arrows are going to go up or down. More specifically, if the leading coefficient is positive, both arrows are going up. If the leading coefficient is negative, both arrows are going down. And you knew this last chapter as If A is positive, it's an up parabola, and if A is negative, it's a down parabola. So you've kind of dealt with that before. But it's true for every even degree function. The leading coefficient positive, the arrows are going up. Leading coefficient negative, arrows are going down. I'm not saying anything about what's happening between the arrows, because who knows? Depending on the function and the degree. Here are some examples. There's your standard parabola. I mean, we got all kinds of things that can be going on between those arrows. There's just some examples. I'm just saying we're talking about the end behavior right now. And an even function, the arrows are going to be going the same direction. All right, so then odd functions have an odd degree, obviously. They've got ends that differ. Odd degree, ends differ. So one's going to go up and one's going to go down. Like a line. A line, one end goes up, one end goes down. If the leading coefficient is positive, it's going to act like it has a positive slope, meaning it rises from left to right. Just like if the slope was positive in a first degree equation. Negative leading coefficient, it's going to be falling from left to right. There's actually a chart on the wall right above the emergency exit with the E and the O and the plus and the minus that just charts out what I just told you. Even, odd, positive, negative shows you the end behavior for all four of those. Okay? Here are some examples of odd functions. Different things that can occur. One arrow's going up, one arrow's going down. Alright, are you ready for a challenging question before I give you your assignment?
Yes.
Here we go. Here's what we know. 5 real zeros means it's going to hit the x-axis 5 times. Doesn't really matter where. Odd degree means one up arrow and one down arrow. Positive leading coefficient means those arrows are going to be there. And all I have to do is connect them through the dots. Really. There it is.